every time I do these questions, I'm trying to be as consistent as I can be. So it says a helicopter traveling horizontally at 150 kilometers an hour to the east. So I'm just going to draw it out. Okay. Executes a gradual turn and eventually is moving at 120 kilometers an hour to the south. If the turn takes 50 seconds to complete, what is the average acceleration? Okay, let's set it up like this. Let's talk about the steps that need to occur. Okay, because then when we start doing other questions, we can look at our steps. And then when you come to me and you say, okay, what did I do wrong here? Well, we can look at our steps and then we can figure out what we did wrong ourselves. It's part of what I was looking at yesterday. It was meant for the grade 9 stuff, but it had something that I thought was maybe better for you guys than it was for the grade 9s that I have. So the first step that you have to do is you write out how you find acceleration given two velocities in time. So my acceleration. So the first step that you do in all of these questions, the first step I'm going to do is I'm going to write out the equation. Okay, now in the last section, we would just then substitute in, right? We would go V2 minus V1 over delta t, and I'd simply answer it, and I'd plug those in. But that's not how we do it, because they're not moving in the same directions. So what do I need to find? I need to find my acceleration. I've got my time. I do have V2 and minus V1. Well, if I just focus on that part of it, my change in velocity. My change in velocity is V2 minus V1. So I'm going to draw my vectors according to my equation. So you draw your vectors according to your equation. So I draw out V2. Well, what's V2?
120 kilometers an hour.
That's right. Okay. Now, what does my equation tell me to draw?
Negative of V1.
Negative of V1. Well, how do I show the negative of any angle?
Opposite.
Or direction, sorry. Opposite. So instead of going east, it's going west. So I have 150. Now because I already have a right angle, I'm not doing components for this because they're both single components. So now, that line represents my magnitude in units for my change in velocity. There's my magnitude, my units. Now, the other thing that you have to find is my direction. And then at that point, all I do is divide that value by my time. That's it. Now, we don't usually use kilometers per hour per second. We use meters per second squared. But in this case, it's okay to use kilometers per hour per second. So what that means is you're going to find a change in velocity in which you're going to have so many kilometers an hour each second. So let's say it was 5 kilometers per hour. After 1 second, I'd be going 5 kilometers per hour faster. After 2 seconds, I'd be going 10 kilometers an hour faster. After 3 seconds, I'd be going 15 kilometers per hour faster. Okay? So your change, your acceleration can be in kilometers per hour per second. That's okay. That's all right. All right? So now all I have to do is Pythagoras' theorem and then use the tan function to get my angle. And then at the end, I divide by time to get the acceleration.
Is that the same thing you do for 4, but like there's 3 points, so.
Well, just,
Alright.
no, we don't do 4. You don't need to do 4.
Oh,
4 is done so that you'd have to draw it. We don't draw it like measure and use a protractor. I don't want that. We just use that. Okay?
So then, when we were talking about writing an acceleration, if you're dividing it by 50 seconds, like
Yes.
your velocity, wouldn't it be, oh, never mind. I got it.
Okay. Okay. We okay?
Yeah.
Yes, sir.
That's page 122.
Oh, just,
Oh, but
yeah. Just let me finish this and then I'll get to yours. Okay? Now, the next question, I 100% guarantee you're going to see again, is that hockey puck question. So instead of, this one's going to be done a little bit different, but again, I still write out my acceleration first. So, hockey puck hits the boards going this way, comes off this way, right? So my V1 is 10 meters per second. That's at 20 degrees right there. It comes off at 8 meters per second, is that right? So my V2 is this direction at 8 meters per second. Okay? And what's that angle? 22? 24. 24 degrees. Okay, so I'm again looking for acceleration, so V2 minus V1 over T. Let's focus on this. Now, I said to you, draw your V2 first. I've got my V2 right here. Now I need to draw the negative V1 from the tip of that one. So what I'm going to do is do this here. I drew it too far down, whatever. Okay? I need to go back in the opposite direction of that. So I draw it up this way, right there, and this is 20 degrees right here. Okay? I'm just setting that in there. So basically what I'm doing is I'm taking this guy, let me do a better job of it down here. Okay? This guy goes up at 24 degrees. That's my V2 right here. Right? So my V1, which was this here, I basically just move it up to right there. Okay? This is negative V1. V1 was actually in this direction. But again, that's tip to tail, V1, V2. I need V2 minus V1. So I draw V2 first, and at that point, I draw my negative V1. So I'm just showing you this because you're going to get confused as soon as you see it. That is 20 degrees. This is 24 degrees because that's what it is right here. So my change in velocity for this guy is somewhere over here. Okay? Now, this is not a right angle triangle. This is not a question that is easily put into a right angle triangle. I would use my law of cosines for this guy. It's one of the three questions that I consider using law of cosines and law of sines for. Every other vector question I use right angle trig. This is one that I would use law of cosines and law of sines for. Okay? So that's that. You guys are going to get to that right away if you haven't got to 6. Fine. That question you will see again. Okay, so you need a 123, Campbell? Page 123?
Or is it 122? Just on the next page, 15 and 16.
Okay, those are those ones. Yeah, again, don't leave 15 and 16 out. Any one that they're asking you to draw using a protractor, just leave. Okay? Other questions from any of these?
Okay, can I pick
Sure.
number 4 on page 103?
airplane is climbing at an angle of 15 degrees to the horizon. Morgan, this is the exact same question. We do it the exact same way. It's not the exact same question, but we do it the same way as the question I did on Tuesday with the projectile, with the cannonball going up. Okay?
Okay.
So, I've got a right triangle, right? With the sun directly overhead, its shadow is observed to be moving across the ground at 200 kilometers an hour. So this is 200 kilometers an hour. It wants its airspeed. This is your airspeed right here. Can you get that? What is it?
107.055.
No, it is not.
I mean, 207.
For my airspeed, I got 193.18.
How'd you get it?
I used right angle, right triangle, sign, I think, something like that.
You use sine?
Yeah, I think I used sign, yeah.
Okay, there's your error. Where is this in relation to that?
Adjacent,
Where is that?
that's a hypotenuse, so it's adjacent over hypotenuse.
Oh, I got that
No,
wrong.
that's
Hold
wrong.
on. Okay, Morgan. Can you do it from there?
So I put down cosine 15, if you cross multiply,
I don't cross multiply. I switch x and cos 215,
Oh, I'm glad.
or cos 15, sorry. I switch those two.
oh, okay. So I think that's what I've been doing wrong most of the time, is I've been using my trig wrong.
Okay. So now, the second part of that question wants you to find y, because then it gives you the constant speed, and you divide it into 1,000 to get your time. So where is this in relation to that?
They're opposite,
This?
adjacent.
Okay, so then you get y, and then you can solve for,
So then it'll be 10 and 15 divided by 200. No, I'm still doing my trig wrong.
you're trying to get y by itself, how do you move 200 out?
Times it.
Correct. Okay,
Stuff. How I do wrong.
okay. Okay, you're good now?
I've probably been doing everything right, diagram wise,
Yep.
but my trig has been what's getting me getting everything wrong.
Okay. Alright, you good to go now?
How did you do the
Okay.
B part of this question?
I just
Oh,
explained it. You were talking when you're supposed to be listening.
I'm trying to figure it out. I thought you were still doing A. That's why we're,
You find the speed that he goes up at, because it's constant.
right, it was, what was
So you got a constant speed, you got a distance. Find the time.
it?
Why do we do 5 right after that? No.
Morgan, you good? I can move to the next one?
Yeah, that's as far as I think I got the page.
Same question. Excellent. Take some 4 seconds
Oh,
to run 25 meters.
okay, well, that's my job. I thought he was running it across
Yes,
as 4 seconds, and I put the distance as my vertical. Okay. My weight made more sense. Okay.
Made more sense if you'd right.
Well, it's the math people. I need to get my group and make these questions.
You should. I think that's something you should look at. Let's have a look at, I haven't done these and I should have done these. Do you have page 106 there or not? I don't think you do.
Yeah.
Yeah, we do.
Do you? Yes, perfect. I thought it came in. Okay, let's look at sample problem 2. So I'm going to spend some time now going through 3 questions with you. All of which, 2 questions with you. I've got one more I'd like to see before, anyways. Okay, I'm going to use sample 2. I'm going to adjust the question a little bit so that I get all that can be asked. This question will be on your, this is a question that's on your test for sure. A swimmer can swim at a speed of 1.8 meters per second in still water if the current of the river 200 meters wide is 1 meters per second to the east, and the swimmer starts on the south bank and swims so that she is always headed directly across the river. Determine each of the following. Okay, so first thing that we're going to do is we're going to draw ourselves a picture. So what I want you to see is I've got a river bank. Looks something like this. Okay? Now, if she was swimming in still water, meaning there was no current, she'd just simply be going this way at a speed of 1.8 meters per second. And I have a distance there. How far across the riverbank is it? 200 meters. Okay? So, it says, what is the swimmer's resultant velocity? Okay, so now, I also have a current. A current is running 1 meters per second this way, to the east. And they want to know, the first thing they want to know is, how fast is this girl swimming? Okay, so I want you to think this through for a second. We want to discuss all of the things that are happening here and how it affects the question. So put your pencils down and let's just discuss this. The first thing I'm going to ask you, I'm going to do this question different. You can answer all your questions after. The first thing I'm going to ask you, what is the minimum amount of time it would take her to swim across the river? How would I find it? No. No.
Like, if she
Divide
was
one straight
across the curtain.
Brendan?
Divide 200 by 1.8.
How come?
Because it's 200 meters and going straight across, it'd be 1.8 meters per second.
That's right. So, to find her actual time that it takes her to get across the river, the shortest amount of time is going to be swimming straight across with no current. That's the shortest amount of time that can happen. Okay? And I'll explain that a little further in a second. So take 200 meters and divide it by 1.8. What do you get?
111.111.
Right. Okay, so it's gonna take her 111.11 seconds. That's the minimum amount of time to cross the river. Okay? Now, as she swims across the river, the current is going to be moving her. So she's actually going to be, if I was standing on this bank here, watching her swim, it's going to look like she goes up and over, up and over, up and over, and she's going to end up down the shore. Right? The current is going to push her. If she still swims, if she's swimming directly across, that current is going to move her down. Yes or no? Yes. All right. Is she going to be swimming faster or slower with the current?
Slower.
No,
Other
faster.
faster.
Faster?
Faster.
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 All right, let's find out.
It's not faster.
I have 1.8 here. I have 1 here. How do I find out what this is?
Multiply.
A squared plus B squared equals C squared. And is that C the hypotenuse? Yeah. So is it going to be larger than the other two? Yes. Okay, so let's do that. Velocity is what? 0.06 meters per second. So if she's swimming directly across, if I'm standing down here, that's me, watching her swim across the river, it's going to appear to me that she's actually swimming at 2.06 meters per second. She's going to be swimming faster because she's swimming with the current. Now, is she going to end up directly across from where she started? No. She's going to end up where? Somewhere down to the east of where she wanted to go, right? She's going to end up somewhere over here. Well, let's find out how far that is. I want to know, how far downstream is she going to end up? Well, how fast is the current moving her? 1 meter per second. How long is the current moving her for? 111.11 meters, or sorry, seconds, right? So how far downstream did she end up? 111.11 meters. The time stays the same. So somebody tell me, explain that to me. How, if she ended up 111.11 meters down there, is the time the same as if she swam straight across?
She's moving faster.
She's swimming faster, but she's swimming
The same.
farther.
So even though distance is increasing, she's moving faster, that's why it equals out?
That's why it equals out.
Okay.
So anytime you're figuring out this question, the minimum amount of time to get across that riverbank is as if there's no current. Okay? So where did she end up? She ended up 111 meters from where she actually wanted to go. That's the entire question. Right there.
Okay, so just.
They're going to say, how long does it take for her to swim across the river? So you take the distance across and divide it by her still water speed. How far down the river does she end up? You take the speed that the current is flowing at and times it by that time. How fast is she moving relative to the shoreline? That's that relative speed right there. Those are the 3 things that get asked.
Another question we'll ask you is what angle the ship
Yeah, okay, just a sec. Yeah, I'm not there yet. Just for this part right here. There's 3 things that happen just at the start of that question. Okay? Now the 4th and 5th thing that happens is they say, at what angle does she need to swim into the current to end up directly across from herself, and how fast is she swimming? Okay? So now, I'm going to change this question. So that's its entirety right there. You've answered everything that it could possibly ask. The only thing that you might ask, I would never ask, but you could, would be, how far did she actually swim? What's the distance from here to here? You could find that. You got 200, you got 111.11, you could find that distance. You could also take 2.06 and divide it by 111.11. That would give you that distance. So there's two ways to find it. Now the question says, here's how it changes. She wants to swim directly across. So she wants to go here. That's where she wants to end up. So she's got to swim then over here in order to end up right there. Yes or no?
Yes.
She has to swim into the current so that she ends up directly across. Do you agree with me? That makes sense, no? All right. Well, how fast does she swim at?
1.8 meters per second.
1.8 meters per second. That's her swimming right there. How fast is the current moving?
1 meter per second.
1 meters per second. Somebody tell me, is she swimming faster or slower now? Or the same speed?
Slower.
Swimming slower. It's going to appear that she's slower, right? Because she has to swim into the current. It's no different than if you run into the wind. It's going to appear slower. Well, look at this. Here's my hypotenuse. There's one of my sides. Let's find out how fast she was actually swimming. How fast is she swimming? 1.8 squared. Subtract 1 squared and the square root of it.
1.497.
She's swimming at 1.49 meters per second.
1.5. if you
Okay.
round it.
Now, the question will ask you, at what angle does she need to swim at relative to the shoreline? Relative to the shoreline is right here. I want to know what angle does she need to swim at relative to the shoreline to end up there. So you need to find this angle first in your triangle, and then do what?
Subtract it from 90.
Subtract it from 90. So I've got sine theta equals 1 over 1.8. Theta equals
33.749.
So what angle does she have to swim relative to the shoreline in order to end up straight across?
56.251.
Jake, does that answer your question? Yep. Okay. How long is it going to take her to get there?
No, it'd take longer.
Shouldn't it always, you said it always takes the same amount of
No,
time
if you're
regardless
swimming with
of
the current, you're swimming against the current now, so it would
You're
be
swimming
longer.
at a slower speed than you would be even if.
So
you
how do I
swam
find it?
across.
So how do I find it?
T equals D times B.
So where are we gonna go? To go rec basketball.
200 divided by 1.497, how long is it going to take?
133.6.
What is it?
133.6.
You will for sure see that question again. Okay? You have to know, and that really, that's a vector question that is very standard and really makes you understand how vectors work. In the first part of this question, she swam with the current, which means that she swam at a greater speed, but she swam a longer distance, which means the time stays the same. In this one, she swam much slower because she was going into the current. Okay? The distance across stayed the same. It was just a matter of how fast were you swimming across. Alright? How are we doing? You understand what I'm doing on this part?
Close though.
Okay?
So why did you make the second diagram?
Because the first diagram, she started by swimming straight across, and then the current moved her that way.
Oh,
In the
okay.
second diagram, she swam into the current so she could end up exactly across from where she started.
So she went west. Like she was,
Yes, that's right.
she was thrown west.
What was the exact direction she went? Relative to the shore, what was the direction she swam?
Mm,
Somebody else give it to me.
East?
What was the direction she actually swam? Exact direction.
West 56.251 degrees.
Yes. She swam west 56.251 degrees to the north. Okay? And that was relative to the shore. So you didn't have to put the west and the north in, but again, let's just test our knowledge here.
So it's west because she swam against the current? When she was swimming with the current, it would have been east? Because the current was moving at east, so if she's swimming with the current and she's moving east. But if she's swimming against
Yes.
the current, then she's moving west.
So she's going north and then east.
Okay, I have another question. If your current wasn't moving at 1 meters per second, that would change your distance?
Yes, so you would multiply it by whatever your time was.
Oh, yeah,
Okay?
okay.
Anybody else on this question here? Like I said, you will see that question again. I can guarantee it.
So find the velocity of the hypotenuse with the information you're given.
Pythagoras theorem.
Yeah. But sometimes you might not be able to be given the velocity. You might need to find it a different way.
Yeah.
No, you'd be given those velocities all the time.
So why were we finding the time?
We need to know how long it takes to get across the river.
Oh, okay. Yeah, I kinda was thinking that on why I asked. Yeah,
There are 4 questions on page 109. 4 questions on page 109. If you can successfully complete this question and those 4 questions on 109, you are pretty much set.
I started one of them.
But those 4 questions are the 4 questions that will make or break you in this section. You need to be able to do the 4 questions on page 109, draw them correctly, and solve those questions. So, my suggestion to you for the next half hour would be to focus on those 4 questions on page 109 and get help if you can't get through them. But those are the ones that are test questions. 2 out of those 4 will be on your test. The third one is very similar to this one. It's a canoeist instead of a swimmer. And then the 4th question on there talks about football again. Okay? Anybody else have questions that you want to look at outside of those 4 questions on page 109? Okay, that should be your primary focus today. How many of you have looked at those questions?
I started number 1 and 2
Okay, so we have to get moving.
on.
You've had 3 days and none of you are at 109 yet. We gotta get going on those. Alright? Okay, if you have nothing else, then you got time to work.
I always should remember, but is there anywhere on this paper that says you co-sign now?
So let's just,
Is there anywhere
plus b squared.
on the,
Plus b squared, bracket divided by 2, b
I said,
squared.
I'll write it down for you.
I don't think it's on that sheet, no.
But then, I don't know. Percentage or equals?
I said,
C squared.
C squared.